My name is Kiara, and today I'm going to be teaching you how to do Exam 1, Question 17 on kinetics and solubility. So, the question is asking to find a compound that dissolves in water and find a liquid that dissolves in water, and also find a compound that dissolves in pentane. So first, let's see what are all the intermolecular forces for water. So we're gonna write water. IMS. Hydrogen bonding. Dipole. And dispersion forces. All of those three. So now let's find a compound that might or that will dissolve in water. So when I think about dissolving, I think about solubility, and then I think about the solubility rules. So the first rule that comes into my head is that group 1A on the periodic table, they're all soluble. So that's like K, Br, I, and A. Also, I know that all chlorides, iodides, and bromides are also soluble. So let's write that too. Chlorides, iodides, and bromides. So, from what I wrote, we can say that KBr is soluble in water for our first answer. Now, for our second answer, we're trying to determine a liquid that might dissolve in water. So when I think about liquids dissolving in water, I think about, the first thing that comes to my head is alcohols, like any type of alcohols. And the most common alcohols that we've learned about is mainly like ethanol, methanol, and yeah. So I think we should use ethanol, mainly because it has all the exact intermolecular forces as water does. So we're going to say it has hydrogen bonding, dipole, dispersion forces. Okay? Now, number 3, it's asking us to find what dissolves in pentane. So pentane is a bit different. Pentane does not have all the intermolecular forces or as much intermolecular forces as water does. Pentane only experiences dispersion forces, and it's also nonpolar. So what compound also experiences the same exact intermolecular forces and is also nonpolar? So I think of all hydrocarbons, like all compounds that contain hydrocarbons, like mainly compounds ending in tane, like pentane, propane, hectane, heptane, all those things. So I'm going to use hectane. So a compound that can dissolve in pentane is hectane. Why? Because it's nonpolar and experiences London dispersion forces. Okay, now the second question that question 17 asks. This one is a bit tricky. It's asking us what solute and solvent solution is stronger than a solvent-solvent solution. So a solvent-solvent solution is basically like water, H2O. So let's write it here. H2O. And we know H2O is water. And we know water has hydrogen bonding, dipole-dipole, and dispersion forces. But there is an intermolecular force that is stronger than all of these three, and it is ion dipole forces. So, what experiences ion dipole forces? Of course, ions. So, let's look at our periodic table. We said these are mainly ions. These are +1 ions. So, let's see what other ions can we use to make a compound that experiences ion dipole forces that will be greater than H2O or stronger than H2O. So I'm going to say NaCl as a plus and a minus, a cation and an anion. So I'm going to say NaCl experiences ion dipole forces. Therefore, it is stronger than H2O, and H2O only has hydrogen bonding. So the solution will form in this solvent-solute being greater than the solvent-solvent solution, or stronger. Now, the second part of the question is asking what solvent-solvent is less than or greater than a solvent-solute, concentration, similar to the first one. So let's use H2O again as our solvent-solvent. And we already know all of the intermolecular forces for water. Now, what is a solvent-solute concentration that experiences less intermolecular forces than water? My guess is a compound that only has London dispersion forces. So similar to pentane, we're going to have to find another compound that experiences only London dispersion forces. So I'm going to say heptane. Remember, these compounds ending in tane usually only experiences dipole forces. Therefore, H2O is experiencing stronger intermolecular forces, and heptane is experiencing the weaker forces. Therefore, a solution will not form. Also, water is polar, and heptane is non-polar as well. And that's how you solve question 17 on exam 1 for kinetics and solubility.